Okay, let's dive into the material you sent over. It's all focused on, well, a pretty fundamental concept, averages.
Mm-hmm.
Our mission, really, for this deep dive is to unpack what these sources are saying is most important about them and maybe figure out why understanding averages actually helps you, cut through all the noise.
Absolutely. And right off the bat, your sources make it clear when we talk average here, we're mostly looking at the mean, or sometimes called the arithmetic mean.
The arithmetic mean.
Yeah, it's the standard one, the one you'll bump into most often.
Got it. So average mean, arithmetic mean, kind of used interchangeably in this context.
Exactly.
Now, the sources, they show the basic calculation. It looks like you just add up all the quantities. Like, there's an example of a man's daily earnings.
Right, the 120 rupees over 5 days.
Yeah, that one. So you add that up, get the total 120, and then just divide by the number of quantities, which is 5 days here.
Precisely. So 120 divided by 5, that gives you an average earning of 24 rupees per day. And the material also points out you got to be working with quantities of the same kind, same unit, like rupees here. And the average itself keeps that unit.
Makes sense. Simple enough for getting a quick snapshot, I guess. Sum divided by number equals average.
Yep, sum divided by number. But, and this is where your sources really highlight something interesting, you can flip that around.
Okay, how so?
Well, if average equals sum divided by number, then it just, logically follows that the total sum must be the average multiplied by the number of quantities.
Oh, okay. So total equals average times number.
Total equals average times number. Yeah, that's a really crucial nugget from these sources.
That is a powerful flip. Like, there's that example of Dinesh's marks.
Mm-hmm. The school mark.
His average in 8 subjects was 35. And the material shows you don't even need his individual scores for this part.
Right.
Just knowing the average, 35, and the count, 8 subjects,
Mm-hmm.
you immediately know his total marks were 35 times 8.
Which is 280. Yeah. It's a shortcut, basically, to get that aggregate number without seeing all the details.
Okay, that's neat. But what's really fascinating, and the examples you sent show this so well, is how that simple rearrangement lets you find missing information.
Yes, this is where it gets really practical.
Like the class of 8 boys, right? Their average height was 168 centimeters.
Okay, 8 boys, 168 centimeter average.
So using that rule, their total height has to be 168 multiplied by 8, which is 1,344 centimeters.
1,344 centimeter total height for the initial 8 boys.
Not good.
Then what happened?
Then a new boy joins the class.
Okay, so now there are 9 boys.
Right, the total number changes to 9, and the average height also shifts. It goes down slightly to 167 centimeters.
So the new total height for all 9 boys now would be that new average, 167 times the new number, 9.
Exactly, which comes out to 1,503 centimeters.
Okay, 1,503 centimeters for 9 boys.
And here's the clever part, the trick your sources point out.
Yeah.
You just subtract the original total height of the 8 boys.
The 1,344 centimeters.
From the new total height of the 9 boys.
Yeah.
The 1,503 centimeters.
Yeah, so 1,503 minus 1,344.
Yeah, and that difference isolates the height of just that 9th boy who joined. It's 159 centimeters.
Wow, okay, that is pretty cool. So you can actually figure out the specific value of something that was added or changed just by tracking how the average and the count changed and using that total equals average times number idea.
Totally. And the exercises in the material you sent, they had a similar problem, didn't they, about school attendance?
Yes, that's right. Same logic. If you knew the average attendance for, say, the first 4 days of the week, and then you found out the average for the first 5 days, you could calculate the attendance just for that 5th day by comparing the totals.
Same method. Find the total for 4 days, find the total for 5 days, subtract.
Exactly. And this, I think, really gets to the core of why understanding this stuff matters, with what you wanted to unpack.
Right.
Averages on their own, they give you that quick, simplified snapshot of a group of numbers. Useful, but basic.
Kind of a summary.
A summary, yeah. But knowing that relationship total equals average times number, it gives you more power. You can either find a total quickly without needing every single data point.
Like with Dinesh's total marks.
Right. Or you can work backwards, like with the boys' heights or the attendance, to find a specific missing piece of data when things change.
So putting it all together from this deep dive into your sources, averages aren't just one thing. They're a tool. A tool that lets you, 1, simplify a bunch of numbers into a single representative value.
The quick snapshot.
The quick snapshot. Or 2, use totals you figure out from averages to find underlying data or solve for unknowns when you don't have all the pieces.
Yeah, it's about getting the gist quickly or drilling down to find a specific bit of the puzzle you didn't have up front.
It really is a surprisingly powerful technique for making sense of numbers without getting totally overwhelmed.
It helps you stay informed without drowning in data, basically.
Absolutely. Which leads to maybe a final thought for you listening. Considering how useful that trick is, finding a missing value when an average changes, like that ninth boy's height or the fifth day's attendance,
Yeah.
where else? Where else in your daily life, maybe at work, could knowing how to use this total equals average times number idea help you understand, or maybe even solve for incomplete information you run into?
Something to definitely chew on.
Yeah, something to think about next time you see an average change.